day for you. So
Good.
like that, oh, okay. So like we all know, I'll be taking you human physiology from the scientific department. Are you with me? So I would like to share my screen. I would like to yes, I would like to share my screen. So are you seeing my screen now, everyone?
Yes, yes.
Yes,
I wonder.
yes.
Wonder. So I'll be starting with human physiology today. So I'm sure most of you have heard the word physiology before, right? If I'm not mistaken.
Yes, yes.
Yes.
It's like I'm having issues with my screen. Most of you have heard the word physiology before, and it's not strange for us. So now let me. I'm looking for a way to get through to this. I'm so sorry.
Yes, please write down.
Can we see this?
Yes,
Can we all see this?
yes, we can.
Yes, yes.
Oh, wonderful. So let me start introduction. So, as you can see, physiology is the scientific study of the functions and processes that occur within living organisms, including the physical and biological system that make up the body. So, when we are talking about physiology, let me use an instance. Looking at the digestive system, you see different organs that make up the system. You have the stomach, you have the large intestine, you have the pharynx, larynx, and so on and so forth. So now, physiology is how those organs work. You get it's different from the structure of the organs, the structure of the systems rather, or the structure of the organs. It's different from the structure, different from how they are made up. You get it is so different. It is not anatomy. Anatomy is how the structure is, how it is made up. You get why physiology is how these organs work. You get it is totally different from each other. So now, in other words, physiology is the study of how living things work. So now human physiology encompasses five systems, namely number one, nervous system, two, endocrine system, three, digestive systems, four, circulatory system, five, respiratory system, and the last one, immune system. But because of time, we will only be discussing the nervous system. Are you all getting what I'm trying to pass across?
Yes, sir.
Yes, yes.
Yes.
Well done.
Okay. So now, the first one, nervous system. The nervous system is a complex system that controls and coordinates the body's functions. So it controls every single function. As long as you are able to defecate, the nervous system has a part in it. As long as you're able to breathe, and as long as you're able to walk, are you getting from one place to another? As long as you are able to speak, as long as you're able to raise your hand and wave it to God or something. It is all from the nervous system. So the nervous system is divided into two: the central nervous system and the autonomous nervous system. So let me start with the first one, the central nervous system. Are we getting this?
Yes,
Yes,
please.
please.
Are we getting this?
Yes.
Yes, yes.
Please.
Yes, yes, yes.
I don't want to just be talking without people getting it.
No.
So now the central nervous system. The central nervous system is the primary control center of the body, responsible for processing and integrating information. What it means there is that it's responsible for processing and integrating impulses. For example, now if I walk up to someone and give the person a dirty slap, what is happening? What will happen there? The skin will obviously feel it, Abby. It will feel it. And there's a reason why you feel pain. The reason is because information has been transmitted to your brain to tell your skin that it should release an hormone called prostaglandin, which is a pain receptor. Are you getting it? It will release that pain receptor and it will make you feel the pain. It's not like as if you are being hit and you will not feel any pain. No, there's a reason why you are feeling a pain. The reason is because of the certain information that is passed from your skin to your brain to tell your brain back that it should release something for you to feel pain. Is everybody getting me?
Clear.
Yes,
Yes.
sir.
Yes,
So
yes.
so it consists of two main parts. The first one is the brain. The second one is the spinal cord. Are you seeing the diagram that I put there? Have you seen it?
Yes.
Yes, sir.
Okay, good. You can
Yes.
see the brain and you can see a cord going down, that spinal cord going down. Good.
Yes.
So the central nervous system is just the brain and the spinal cord. Now let me move to the next one. So now the brain. The brain is the control center of the body responsible for processing sensory informations, controlling movement and coordination, regulating body functions, e.g., heart rate and breathing, and facilitating thoughts, emotions, and behavior. Now, let me explain this. The first part is the control center of the body. Obviously, we all know that we are not babies. Responsible for processing every sensory information, every single information, like I explained before, pain of a thing. It is the brain that is obviously. I explained that from the skin will tell your brain that you should tell the skin back to release pain receptors. I explained that before, so you know that it is responsible for processing every single sensory information. The controlling movement and coordination, from moving from point A to B. It is your brain that is obviously controlling all these movements and sorts. Regulating body functions like breathing, like heartbeats, like sneezing and all sorts, and defecating, urinating, every single movement and action of the body. It is your brain that is obviously controlling all these Are we getting it
Yes.
from this
Yes.
place? Okay, the
I
brain is
think
divided into
from
three
some
major
and
parts.
from here.
Now, okay, good. The brain is divided into three parts: the forebrain, the midbrain, and the hindbrain. So now I would show you. Okay, are you seeing this diagram?
Yes, we can see it. The forebrain, midbrain,
Yes.
and hindbrain.
Okay, yes.
Yes, we can see it.
Okay, so now you can see the way they are divided. The forebrain is in front. FORE is from the word before. You get, like, use the word before, something in front. You get four. Are you getting it? The midbrain is the next one. Midbrain is in the midway at the midpoint. Are you getting it? So the hindbrain is behind the ending, like the back parts. You get it? Does everybody understand this?
Yes.
So now let's start with the forebrain, shall we? The one in front. So now the forebrain. So the forebrain is the most anterior part of the brain, responsible for various higher level functions. And it consists of two major and two minor parts. Are we getting it? So now the two major parts are the cerebrum, and the second major part is the olfactory lobes. The two minor parts are the hypothalamus, and the second minor part is the thalamus. Are we getting it? So now we have I picked out the forebrain for you. Are you getting it? Now we are going to break it down. Are you getting it? Let's start with the two major parts before we enter the two minor parts. Are you getting it? Does everybody understand what I'm saying?
Yes.
Yes.
Okay, good. So now the cerebrum. So now the cerebrum is the largest part of the brain, responsible for processing sensory informations, controlling movement, and managing higher level of cognitive functions. It is divided into two hemispheres, left and right hemisphere, and as follows. Now let me not read from this note. Let me explain it well to you. The cerebrum on its own, are you getting it? Is the largest part of the brain. Are you getting it? Is the largest part of the brain. Though it resides in the forebrain, but it is the largest part of the brain. Do you get it? So now the cerebrum on its own controls different things. The first one is that it controls voluntary activities. Voluntary activities like flying the window when your teacher doesn't permit it. Voluntary activities like protesting is a voluntary activity. I mean, voluntary activities like moving from point A to point B. You get it. Voluntary activities like movement, like what example? Give me. Can people give me examples of voluntary activities? I need
Like
response
singing.
from thinking. Yeah. No. Oh
No,
yes.
eating. I said eating.
Eating. Okay, eating. Yeah, wonderful. I hope you shall get what I mean by voluntary activities. So every single voluntary activities is from this part of the brain called the cerebrum. You get. So the second one is another function is that is the seat of intelligence. You get every single logical reasoning reduced from that brain, from that part of the brain called the cerebrum. Every single mathematical equations, the fact that you are able to even answer questions well is from the cerebrum. You get the fact that somebody gives me a book, I am able to read it and understand it well. And the fact that I'm able to summarize it in my head, it is what from the cerebrum. You get it? Does everybody understand what I'm trying to say?
Yes.
So the two functions I just read out now. Number one is voluntary activities, Abi. Every single voluntary activity is from the cerebrum. Number two is retrieving long-term and short-term memory. Do you get it? So every the incident that happened yesterday that my brother took my bread without my permission is from the cerebrum. Obviously, long-term and short-term memory is being stored there. You get. So now I didn't finish the overview. Now I'll go back there. I said they're divided into two hemispheres. Okay, now those short people that are your friends, are you getting this? You
Mm-hmm.
can stand in front of them now, look directly on top their head. Are you getting? It's like a big oval. So now divide that oval into two. That's what we are dealing with. Do you understand? The part at the left is the right. It's the right at the part at the left is the left hemisphere. The part at the right is the right hemisphere. Do you understand what I'm trying to put at?
Yes, yes.
So you stand in front of those short people, look on top their head, and you divide it into two. The left one is the left hemisphere, the right one is the right hemisphere. So now each of those hemispheres are now divided into four. Each of them, they are individual hemispheres, the one at the left, the one at the right. So each of them, the first one, let's take the left one as an example. We have the frontal lobe, we have the parietal lobe, we have the temporal lobe, and we have the occipital lobe. So let me go to the next slide. I think I should have something like that. Can we see this?
Yes,
Can we
sir.
see
Yes.
this?
Yes.
Okay.
Yes.
I hope what I'm saying is not too much or too small, right? Or is it relatable?
It is nice. It's just in time. We have like limited amount of time here, so it's good that you're touching it and you're explaining and you're carrying
Okay.
us along. So it's fine for me.
Okay. Good.
For me.
So now this is one hemisphere. Are you getting it? This is one hemisphere. We have the frontal lobe, we have the parietal lobe, we have the occipital lobe, and we have the temporal lobe. So now let me start with the occipital. The occipital lobe is anything at the back behind. The word occipital lobe is from the word occiput. The occiput is the people that have ogo, that ogo. When we were younger, we don't call it ogo, we call it elongated occiput. Why, Abi? Because the occipital bone is behind the head. Are you getting it? So those ones that have ogo, they have that very big occipital bone. You get what I mean? So now the occiput means anything at the back. Are you getting it? So now are you seeing what I'm doing here? This is the function of the occipital lobe. The first one, the one in green, the one in green, I mean lemon. The one of the functions is visual awareness, visual, and the second one is visual processing. Visual awareness is the fact that I am standing in front of Lagbaja, or let me use this for Chinedu. I know that it is Chinedu. Are you getting it? My eyes is doing the seeing, obviously, but there's something here that is making me aware that this is Chinedu I'm seeing. Are you getting it? So now the second one is visual processing. Visual processing is, obviously my eyes is looking at it, right? My eyes is looking at it. So there's something in the brain that is processing it for me to be aware that this is Chinedu. Are you getting it? So it is that simple. So now the second one is the frontal lobe. Frontal lobe is in front. So for frontal lobe, we have the functions is abstract thoughts, explicit memory, mood, motivation, decision making, etc. etc. So now we have the parietal lobe. The parietal lobe has to do with taste, somatic sensation, sensory integration, visual processing, etc. etc. Now we have the temporal lobe. The temporal lobe has to do with hearing, smelling, emotion, learning, etc. etc. Now, you know I explained before that frontal lobe has to do with anything in front. The occipital is at the back. The parietal is on top, while the temporal is below. You get it? So now let me move to the next one. So now I'm done with the first one. That is the cerebrum. The cerebrum has to do with voluntary activities, etc. So now we are dealing with the olfactory lobes. So if you can see here, I put that the olfactory lobe is known as the olfactory cortex. These are the part of the brain that processes smell. So what the olfactory lobe does is this: it releases sensory impulses of smell. You get those sensory impulses of smell is what that would make me aware that something is burning in my house. You get it will make me aware that somebody has body odor. You get what I'm trying to say. So, but I think I explained before that. Okay, yes, they are located in the forebrain, specifically in the temporal lobe. That temporal lobe that I was talking about, they are located there. So now let me skip all this nonsense. I hope you understand what olfactory lobe is. So now
Yes, sir.
damage to the olfactory lobe can cause asomia. Asomia is loss of smell. Hyposomia is reduced sense of smell. Parosomia is distorted sense of smell, and etc and etc. So now let me move to the hypothalamus. No, so now I've dealt with the two major parts. Now I mentioned the two minor parts. When we are dealing with the cerebrum, I'm sorry, when we are dealing with the forebrain, I explained that there are two major parts and there are two minor parts. Now I mentioned the two minor parts of the forebrain. So one of the first minor parts is the hypothalamus. So the hypothalamus is a very small crucial region in the brain, located below the thalamus and above the brain stem. It plays vital role in regulating body temperature, hunger and thirst, sleep, wake cycle, etc. So now for the regulating body temperature, when you have malaria, the reason why you have malaria is because one stupid mosquito came to bite you. It now injected into you its baby. I would like call it its baby, but use your it injected into you an organism. So the organism is called plasmodium. You get so now plasmodium now goes into your body, now finds its way to the hypothalamus. So now the hypothalamus now the when it now gets to the hypothalamus, it now because since the hypothalamus is one regulating body temperature, it now distorts the whole thing and makes it instead of you to be feeling cold, you are feeling warm. Instead of you to be feeling warm, you are feeling cold. It just goes there and distorts the whole thing. You get. So now the next one is regulating hunger and thirst. Then sleep wake cycle, etc. So now the thalamus. The thalamus is so did you see this diagram I drew? I say I drew the diagram I put there rather. So
Yes.
next one is the thalamus. The next one is the thalamus. So now I explained before that the hypothalamus I explained before that the hypothalamus is located below the thalamus, right? Located below the thalamus. So the thalamus is a small egg-shaped structure in the brain, playing a crucial role in sensory processing, information regulation, attention and focus. Some people even have issues with this attention and focus. There are several patients in the neuropsychiatric hospital that have issues with this attention and focus. It's called attention deficit syndrome. Most of them have heard of it. If you are in front of them, I don't even know how this thing works. They are focused, they are not focusing on you that is talking. You are talking, right? They are hearing you, but their mind is focused on the ceiling fan that is rolling. That is another illness entirely. So it's also one of the functions is also pain modulation, sleep wake cycle, etc. So now um damage to the thalamus can result to sensory deficits, cognitive difficulties, sleep disorders, pain disturbance, consciousness impairments. So now I'll be moving to the midbrain. So I've dealt with everything that has to do with the forebrain. I am moving to the midbrain now. So now the midbrain is also so the midbrain. Okay, so the midbrain is also known as the Mensecephalon. Mensecephalon is from two different words. Are you getting it? Meso means middle. Meso means middle. Cephalon means brain. Are you getting it? So middle brain in a way. So now functions of the middle brain, of the midbrain rather, auditory processing. That has to do with relay sound information from the ear to the forebrain. Visual processing involves in eye movements, pupil constriction, blah blah blah. Motor control, pain modulation, blah 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 blah. So now let's enter the hindbrain, the last part of this whole thing. The hindbrain. So the last part of the three parts of the brain. So the hindbrain. And hey, I forgot something. One of the functions of the midbrain is that it connects the fore and the hindbrain together. It is very crucial in sending information from here to there and here to there, here to there, here to there. You get, since it's in the middle. So now the hindbrain. The hindbrain is also known as the rhombencephalon rather, rhombencephalon, which is the lower part of the brain stem. Are you getting it? So now the hindbrain plays crucial role in sensory processing, autonomic functions, motor control, sleep and arousals. So now divisions of the hindbrain. So the first division is medulla oblongata, the second one is pons valori, the third one is cerebellum. Now I'll take this one by one. Medulla oblongata has to do with involuntary activities. Involuntary activities like breathing, heartbeat, digestion, excretion, heart rate, any involuntary activities. You got it from the medulla oblongata. So now let's go to pons valori. It involved in sleep, arousal, sensory processing, etc. etc. So now for the cerebellum coordinates movement, balance, and posture. The fact that I'm able to stand right and not fall to the side, it has to do with my cerebellum. You get. So now we are entering the spinal cord. Does everybody understand what I've been saying? Does anybody have any questions? Does anybody have any questions?
Not for now, for me.
None for now. Okay. Please, oh, don't forget to ask questions. Oh. So now the spinal cord. I've been rushing because of time. Please, oh. The spinal cord. The spinal cord is a vital part of this CNS, which extends to the base. So the spinal cord is starting from where the medulla oblongata of the brain. Who's that? Does anybody want to say something?
Yes, please, sir. Can you please calm down? You are too fast.
I'm too far. Okay, so it's just the time. No, don't be angry, please. It's just the time. So now the spinal cord, I'll be slower. Wherever the meeting stops, it stops. I'll be slower now. So now the spinal cord is a vital part of the central nervous system that extends to the base of that extends from the base of the brain to the lower back, protected by the spinal column. So now the spinal cord starts all the way from the medulla oblongata, this side in your occiput, this back of the brain, down to the pelvic bone. Are you getting it? From the base of the brain down to the pelvic bone. So now the spinal, one of the I say one of the functions of the spinal cord is that it transmits messages between the brain and the rest of the body. How it does that is there are certain nerve endings that are usually attached. Imagine a pole now, a pole, and it attach wires to it. Those wires are the nerve endings. Inside those wires are neurons. Those neurons are the ones that are responsible for transmitting impulses. You get from the brain to the rest of the body. Those neurons that send messages to your brain. Messages like if you hit your leg on a stone, you remember that the spinal cord has nerve endings that are attached to different parts of your body. So don't forget it's also attached to your leg. The fact that you are receiving pain from your leg, so the nerve endings will now, there are neurons inside the nerve endings, don't get me wrong. The neurons that are there now transmit information from your the rest of your body to your brain that you are feeling pain. Are you getting it? So now controlling movement, voluntary and involuntary actions, like, so the spinal cord controls all actions, both voluntary and involuntary, like walking, breathing, and digestion, every single thing. The next one is regulatory function, regulating functions. Functions like heart rate, blood pressure, body temperature. The fourth one is processing sensation, like I explained before, like pain, touch, and pressure. So now this is the spinal cord. You get the spinal cord is divided into four. We have the cervical, we have the thoracic, we have the lumbar, we have the sacral. So now look at those nerve endings that I explained before. Those things like wires. Are you getting it? But they are longer than this, reaching different parts of your body. Are you getting it? Is everybody understanding what I'm trying to say? They are longer than this. These wires that you can see attached to this they are longer than this, reaching different parts of your body. You get. So now for the cervical vertebra, from the C1 to the C4 has to do with head and neck movements. Are you getting it? The C4, I'm sorry, the C2, okay, from the C1 to C4 and C2 has to do with breathing, head, neck movement. Are you getting it? Then from C4 to C6 has to do with heart rate. Then C5 has to do with shoulder movements. You get. So wrist and elbow movement has to do with C5. So each of these nerve endings, those things like wire that are attached to the spinal cord, have millions and billions of neurons inside there that are just rest. Just for example, now these wires that you from your DSTV to the switch, the wire is there quite right, but there's something inside the wire called the copper that transmits the electricity. Are you getting? So imagine the copper inside be millions and billions of neurons transmitting those impulses to your brain. Are you getting it? So that is did with central nervous system. Please, you can ask your questions now. The reason why I was rushing was because of time. This meeting has been timed. Please, does anybody have any question?
No, no, no.
Or should I move on? Okay. Don't worry, we'll get to that place where you ask questions. You can ask as many as possible. You know? So now the peripheral nervous system. So now the peripheral nervous system. It is the part of the nervous system that connects the brain and the spinal cord to the rest of the body. Are you getting it? So now those nerves I was talking about are part of the peripheral nervous system. Are you getting those nerves? Those sensory receptors that are transmitting information from up, down, everywhere are part of the peripheral nervous system. So now the peripheral nervous system consists of the nerves. So those bundle of neurons that are transmitting signals from the brain between the brain and the body. You get. So the next one is ganglia. Ganglia is the cluster of neurons that act as relay stations. So obviously, if you are taking a train from a place from one junction to another, there are particular stations you stop at, right? To drop maybe drop somebody or drop just shout to drop somebody. You get. So those are relay stations. So imagine if I get maybe I get punctured at the leg. Normally, the brain is getting information from my leg that somebody has that I have been punctured. But there's a juncture. There's a juncture where it will break down first. It won't just send everything straight like that, all the pain at once. Your body has that way of breaking it down small small until it gets to that point. Are you getting it? That's how it is. So now the sensory receptors, they detect changes in the environment and send signals to the brain. So now subdivisions of the peripheral nervous system. The first one is the somatic nervous system. The second one is the autonomic nervous system. Now for the somatic nervous system, it controls voluntary movement, sensation, and reflexes. It consists of different type of it consists of efferent neurons, and sensory receptors. So now for afferent neurons, they transmit sensory information from the body to the brain. Are you getting it? Efferent neurons, they are the ones that transmit motor signals from the brain to the muscles and glands. Are you getting? So the sensory receptors they detect changes in the environment and send signals to the brain. So now, functions of the somatic system or the somatic nervous system. The first one is voluntary movements. Voluntary movement like walking, talking, etc. etc. Then the next one is sensory perception, receiving and interpreting sensory informations from the environment. So the last one is reflexes. The fact that I'm able to remove my hand from a very hot pot, you get, is from the somatic nervous system. So now for the autonomic nervous system, the autonomic nervous system coordinates and controls involuntary activities. You get. So now involuntary activities like heart rate, etc. etc. So now divisions of the autonomic nervous system. One is nervous system. The second one is parasympathetic nervous system. For the sympathetic nervous system, it prepares the body for emergencies. You get emergencies like, for example, now if I'm standing at a junction and I hear one ball, one ball, one ball. What do I do? I don't even know. I just start running. I won't even think of my slippers. I won't think of the next person beside me. I just start running. If there's a dog coming from nowhere, I just dust my slippers and without even thinking of it. Why? Because the sympathetic nervous system is the flight and fright response. Are you getting it? It helps you by increasing heart rates, blood pressure, and energy levels. It helps you by most of you when you are afraid after the whole scenario of you being afraid, you start tasting something and bitter in your mouth. You get so the somatic nervous system releases a bit of bile actually to help you with the whole process. So now for the parasympathetic nervous system, it is all those things that has happened. The increased heart rate, the dilating of pupils, everything, the releasing of bile, it restores it back to normal. That has to do with the parasympathetic nervous system. So you can see it here for the sympathetic. The sympathetic is at the left, the parasympathetic, the differences is left and right. So now let's go to voluntary activities, voluntary actions rather. Voluntary actions are known as voluntary movements, actions that are consciously controlled. The one that you deliberately do, the one that you know about is voluntary activities. You get. So this, so let me move to the next one, involuntary actions. Sorry, I'm rushing because of time. Involuntary actions. Involuntary actions are also known as involuntary movements. Okay, no, I think most of you can control I say most of you, all of you can control your heart rate, your breathing, your digestion. You can't. These are actions occur without conscious control or intention. You get, they are automatic and reflexive. So now, So now for reflex actions, actually they are actually due to response to stimuli. For example, now if I touch something else, I immediately move my hand. What is that? Is response to stimuli. What's the stimuli? The stimuli. What caused it? What caused it? And what is the stimuli? The stimuli is the dust or something that entered my nose. Something that triggered the action. Are you getting it? So I think this. Sorry, I've been very fast. I need to entertain questions, as many as possible, to compensate for my rushing. Anyone on the line? Please
For
ask me
now,
questions. Please ask me as many questions. I'm so sorry, I was rushing. This topic, you're not supposed to rush. It's supposed to be like 3, 4 hours topic. Please, okay. I need to entertain questions. No one? No one? Or you understand everything?
you mentioned a part of, like, I don't know, you mentioned something like there are some people when you are talking to them, they are there physically. Do you understand? I don't know if you can expatiate on it. Like they are there physically. You are talking to them. It looks like they are looking at you. The what's it called? Even their body movement and everything might look like they are looking at you, but they are not there. This question is quite personal. I want to know the exact reason why. Is
Okay,
it
it's
like
personal.
sometimes you
Okay,
feel like it's
actually,
this? Yes, like is it distraction? What is it? What causes that? Because most times,
okay,
you,
to them it's actually a neuropsychiatric condition. It's a mental illness actually. It usually starts from when they are babies or when they are young. You would maybe you throw something at them now. They are looking at
okay,
the dog that is running. I don't know how to explain. It's called attention. When they're supposed to focus their attention, they are not focusing their attention on. If I'm standing in front of them and showing them something, they are not looking at me. They know that I'm there, but their attention is not on me. Their attention is on the next person beside me. It's actually a neuropsychiatric disorder, a very
okay.
big one.
Thank you very much. Thank you very much.
Good
Another
evening.
one.
Mr. Stephen, thank you so much for your lecture this evening. It's really educating.
Yes, ma'am.
Please, I want to ask for this explanation you just gave now. How will you now know, or what are the signs? How will you know that a child, like from you said, it happens from birth, right? So how will you now discover it in your child? How? What are the signs? What are the things you need to observe in a child to know that this person has this? Thank you.
Okay, thank you so much for that. But this wasn't part of the topic, oh. But anyhow, Sha. So one of the first things you do observe is that let me give instances. Can we all hear me, please? I don't know if my network is failing.
I can hear you. I can hear you
Yes, we
clearly.
can hear you.
So one of the things you first observe is that they don't be crying anyhow at first. You notice that I don't know how to explain, like they might be, for example, all those ones around maybe age two, age one, age two, age three, they will be crying that they want something. If you give them that thing, they'll start wailing. I don't know how to explain it. They want, maybe for example, now they are like, I want biscuit, I want biscuit, I want biscuit. You give them biscuits, they will just get angry for no reason and be like, no, mommy, I said I didn't want biscuit before. I said I wanted chin chin. I hope you're understanding what I'm trying to say. From there, it's not like as
Yes,
if it's
right on.
every
I
child that
understand.
does that. It's not that it's every child that does that that is having issues. Oh. No, that is one of the few symptoms. The second one is that if you take them to school now, like school and maybe then they start school, you notice their teachers will actually give you these complaints that they are not following with the class. How will I explain? Maybe the teacher is like A B C D E F G, and they start looking at the teacher and instead they are quoting something else, something that is not even, they can start singing Bani. He said that, so you get what I'm trying to say. It's very, that's
Yes,
one, you get what I'm trying to say.
yes, right on.
And another thing is that maybe from that age three, age four, you might be talking to them about biscuits. Now they might be like, mommy, and the sky is blue. You get what I'm trying to say?
That's very
Like
serious.
they'll be talking off. They'll be talking off key.
Um, he's not. They might not. He's not all of them. To you get at least those few ones that I have to. You get, and they will not. They don't look at people face to face. I don't know how. I don't know why that is even like that. They won't like to look at you eyeball to eyeball. They'll be trying to dodge that your eye. If you get what I'm trying to say. Most parents might actually say because they are shy, because they are shy. They are shy. They are shy. But from shyness, they can enter.
Okay.
You get what I'm
The
trying to
thing
say.
is, the way you are describing it, this is like on a very serious level. The way you are describing this thing, because the reason why I asked that question is because that's why I said it's personal. For so you can be talking to me, I might be sitting down here, but I'm not really here. But it does not happen most. It does not happen all the
No, the
time.
thing that
It's
it
not as
starts from
serious as this because at a point,
I get that.
it's like
I
I'm
don't
getting
think
scared.
you might have something like that because it actually starts from children, not those from age three, four, and so on and so forth. You get toddlers first. They would have noticed this when you are a toddler. They can't just you get.
Yeah, hello everybody.
Okay, because I don't know, some of the peculiarities are not there for me, like not being able to look at somebody and all of that. But thank
Yes.
you very much.
Okay.
I
Thank you.
enjoyed your
I
session.
think there
Thank
are
you.
many people that have questions. Mr. Paul, then Miss Additional. So they've been trying to raise their hands. Can Mr. Paul go ahead with his
Let them.
question?
Is there a way? They can,
Mr. Paul, can you go ahead with your question? Thank you.
is there a way I can get their questions? Okay.
Is Mr. Paul still with us? Okay, if it's okay,
Sorry,
yeah.
can you hear me?
Yes, please.
I can hear you. I can hear you.
Sorry, I'm like
Yes, you
outside.
can.
That's why. Okay, I have a quick question. I I joined late, so I'm really sorry about that. But at least I was able to pick up some
Okay.
things. It was very good presentation. I like the presentation you gave. So I have two questions basically. I know
Okay.
I have a little bit of idea of the central nervous system and the whole peripheral nervous system, but there's one
Okay.
question that is always on my mind that I've been trying to figure out, even though I've done a little bit of research, which is the
Okay.
relationship between electrical signals in the cerebrum. Yes, that's your forebrain.
Okay. And
So
what?
I want to and intelligence. So
And
I want
intelligence.
to know is if you have sharp or if you have more electrical signals in your cerebrum, would you say it is directly proportional to intelligence? So would you say the more level of gray matter I have in that section of my brain, would you say the more of it I have, the more intelligent I can become?
Well,
That's my first
well,
question.
yes, because I you know that the gray matter is actually where the main logical reasoning is in the cerebrum, the cerebral cortex, right? If I'm not mistaken.
Yes.
Okay, good. So you are trying to say the more gray matter you have, or the more larger, will you want to say the more larger your cerebral cortex is, right? Is that what you want to say?
No, not necessarily. It's just more of like the electrical connections and the electrical stimulations that happen in that section of the brain.
Okay, now one thing you might need to know is this. Have you heard of madness before? Have
Yes.
you heard of being mad? Then
Yeah,
I don't
yeah.
even need to talk about it. Yes. So there's something that happened to someone I knew a long time ago. Are you getting this?
Yes.
You feel the more gray matter you have, the more wiser you be, and things like that. I think have fooled most of us, but it is not like that. You will see certain people in the psychiatric hospital and you will meet them and they will ask you, you'll be like, what's wrong with you? Why are you here? I met someone that can solve whatever something I do can solve anything. Are you getting if you bring any mathematical equation to her, she will solve it and everything. So now listen, are you getting it? So there's somebody that is she believes herself.
Wow. Okay.
There's someone that she believes herself. I mean, so
Okay.
that's what
I just really wanted to know the connection because sometimes I feel it is, sometimes I feel it's just a myth. So I just want to know, like, I need to get another perspective to what it could actually be, because when it comes to the human brain, there's a whole lot of places we've not explored yet. I think they say we just use only 10%. I think the highest is 10% of the brain. So the other 90%, why can't we access them?
okay, I don't know your questions.
Yes, that's the first. This is the second question now. Like the other 90% of our brain that is inaccessible yet, why can't we access them? What is the blockade? What is stopping us from accessing the other 90% of our brain? Why can't we access those aspects of our brain?
That question is extremely how would I put it? We rhetorical. There's nothing like you using just said it. Clarity said it. But I think the improving medicine. Even I've heard of that a long time ago. And they say you only use 10% of your brain to look at it. Scientists have not proved that, and medically is not proven. It's just a myth.
Are you sure about that?
Yeah, I'm sure.
Okay, no problem. Thank you.
So anymore, Animal.
Miss Additional, are you there? I thought you wanted to ask a question, please. Okay, Miss Vivian, are you still with us? Miss Oluwafermi, are you there?
Yes, I'm still with you, people.
Okay. Miss Vivian, write down with your question, please.
Yes, I'm here.
Thank you. Miss Vivian, please write down with your question. Thank you.
Sorry, I have no question. I've already asked the
Oh,
question
there's
I wanted.
somebody, Damola Adebite. Mr. Damola, please can you write down? Can you start? Kind of ask a question. Thank you.
Mm,
Alpha. Hello.
can you hear me?
I can.
Oh, okay. So my question is this: when someone gets affected, maybe a partial stroke or something like that, what part of the brain gets affected?
You actually someone have partial stroke. What part of the brain is affected, right?
Yes.
This is what actually happens in stroke. Imagine a pipe. Are you getting it? And someone steps on it. The way it is rushing so fast and it breaks out. But then there's a spill of blood on the brain. That's what actually happens to the during stroke. Are you getting it?
Yes.
So that's not one part is being affected. No, not that a particular part is being affected. Are you getting it?
Yes. Yes.
So it depends on where the spillage is.
Okay, if there is no other question, can Mr. Stephen just round up everything? Thank you.